Hi, so today we'll be talking on audio compressor. Although this topic is a little bit complex, but I'll try my best to make you understand. Okay, just I will advise you to move step wise with me. So what is an audio compressor? An audio compressor is a dynamic audio signal processor which helps to decrease the dynamic range of an audio signal by automatically lowering the louder part of that audio signal. Okay, as per its parameters set. So what is the dynamic range of an audio signal? Okay, in an audio signal there are various sound frequencies at various peak amplitude level. So to calculate the dynamic range of that audio signal, we consider the lowest peak amplitude and the highest peak amplitude. Obviously there are various other peak amplitudes, but we are taking into consideration to only the lowest peak amplitude and the highest peak amplitude, and that gap would be the dynamic range of that audio signal. Now I'll show you this information in the audio waveform. So let's see. Now in this audio waveform you can see the lowest peak amplitude is here and the highest is here, and in between the highest peak amplitude and the lowest peak amplitude there are other peak levels. Okay, so we are considering only the highest and the lowest to calculate the dynamic range of an audio signal. So this distance, this gap would be the dynamic range of this audio signal. Here I have made one more audio waveform to make you more clear. So in this audio waveform you can see the highest peak amplitude is here, and the lowest is here, and there are other peak amplitudes. Okay, this. So we are only taking into consideration to the highest and the lowest. So this is the dynamic range of this audio signal. I hope this is clear now. So now let's talk about the parameters of an audio compressor. So the basic mandatory parameters would be threshold, ratio, attack, release, and makeup gain. Although there are various other fancy parameters as well, like dry wet mix, hard soft knee, sidechain, etc. and etc. But this threshold, ratio, attack, release, and makeup gain are mandatory. These are the mandatory parameters that must be present to form an audio compressor. So now we'll be looking at those mandatory parameters theoretically as well as practically. So let's see now. So this is the basic view of an audio compressor. So here you can see there is threshold, okay, ratio, attack, release, and makeup gain. So now let us see on all these parameters one by one. So first we'll be looking at threshold. So you can see the threshold value is measured in dB, and what this threshold option in an audio compressor does is it tells exactly the audio compressor when to act on. For example, so here you can see the threshold is set to -20 dB. So what this says is whenever the audio signal crosses the threshold value, this -20 dB, it says the audio compressor to act, and whenever the audio signal is just below this threshold value -20 dB, there will not be any compression acted. So this threshold option simply triggers the compressor. It simply says when the compressor should act and when should not. If the audio signal crosses the threshold value, the compressor should act, and if the audio signal value is below the threshold set value, here -20 dB, the compressor is not acted. And one important thing, the audio compressor is acted only in this threshold excess value. Okay, suppose the highest peak amplitude is here, and the threshold value is here, and the compression is acted only in this area, not to the audio signal which is below the threshold value. We'll see it in more depth little later. Just understand here theoretically. I'll show you practically a little later. So now ratio. So you can see the ratio. So ratio is in the form of x is to 1, and this x can be any number. It can be from 1 to any. And if the ratio is 1 is to 1, if this x is 1, there is no compression applied. So to apply compressor, there must be value greater than 1, and this value is measured in amplitude, okay, dB. So what this x is to 1 says is, for every x dB of an audio signal, it will be reduced to 1 dB. For example, if this is the total peak amplitude of an audio signal, so this is the threshold, okay. To below the threshold value, there is no compression. The compressor is only applied to this area. There is only compression in this area, not in this area. So what this x is to 1 says is, suppose for every x, okay, it can be 2 also. Suppose here 1 for every 2, okay, for every 2. Let us suppose this axis dB was 6 dB. So here 2, 2, and here 2. This 2 will be 1, and this 2 will be 1, and this 2 will be 1. So 1, 2, 3 dB, okay. So the axis can go only up to 3 dB of the threshold value. 2 and here 3, somewhere here, okay, somewhere here. The final audio signal peak amplitude will be here, somewhere here. And don't worry, I'll show you practically also. First, I'm only focusing here in theory portion, okay, so that you understand the concept first, okay. Third, attack. This attack time is measured in milliseconds. You can see here milliseconds, and for the information, 1000 milliseconds is equal to 1 second. So you can see it is a very less amount of time, and all the magic happens in this short period of time. So it's very important to understand. So what this attack option in an audio compressor does is, whenever the audio signal crosses the threshold value here threshold value, and the audio compressor has to act. And this attack means how quickly the audio compressor acts. It's simple as that. It simply means how quickly or how lately the audio compressor acts fully. Now another, release. And you can see the release is also measured in milliseconds. So what this option does is, whenever there is audio compressor acted, now there will be the situation when the audio signal will be below the threshold value. So at that time there should not be any compressor acted. So it says, whenever the audio signal is below the threshold value, how quickly or how lately the compressor should fully come to stop, okay. Straight to the point, this. Now let's see makeup gain, or just gain, and it's measured in amplitude dB. So just to point one thing, we want sound loud, but what this audio compressor is doing is, decreasing the loudness. So this makeup gain will increase the loudness without affecting the dynamic range, because with compressor we have already decreased the dynamic range of an audio signal, and if we use this makeup gain, the overall loudness of that audio signal, okay, will be boosted, and this lower portion of the audio signal can really come to high than before, because if the gain was applied without an audio compressor, and there would be the huge dynamic range, okay. So increasing a little bit of amplitude will result in clipping of that audio signal, but with audio compressor we have already decreased the dynamic range. Now we have option to increase to more option. So in this way, this makeup gain is very important. Now I have explained every compressor parameters, basic parameters theoretically. Now I'll be showing you all those things which I have said practically. Now we'll start the practical session, okay. Now in this session I'll be demonstrating you everything which I told you theoretically. So now let's see. Now let's see all that we talked in theory practically, okay. So here in x-axis we have audio frequencies, and at y-axis we have a peak amplitude of our various audio frequencies, and this is regarded as the peak amplitude level meter, and this is this red is the ceiling. Above it the sound will be clipped, will be distorted. So now let's suppose the highest peak amplitude of an audio signal is minus 5 dB. So we put threshold to minus 20 dB. Ratio to 2:1, and attack and release to the fastest possible. So our given condition is this much, and you can see here this minus 5 dB is our peak amplitude, and the threshold is set to minus 20 dB. See here it is. This is our threshold, and our ratio is 2:1. And what this says is now the audio signal is going up to minus 5 dB. Now for every threshold access signal from here to here, there will be compression applied. So this ratio 2:1 means for every 2 dB of access audio signal, it will be reduced to 1. Okay, so from here to here, this much is access. So the 2 will be minus 18. This 2 will be decreased to 1, and again this 2 from 18 to 16, this 2 will be 1. Okay, and again this 2 will be 1, 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 and here it's only 1. Okay, 2 for 1 means 1, if there is only one, it's half. Okay, 0.5. So now let's count 1 2 3 4 5 6 7.5 here. Here is 0.5. Okay, it's 7.5 dB. Now this before it was 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Before it was 15 dB. 15 dB is reduced to minus 7.5 dB when the audio compressor is applied. So the final output would be at 1 2 3 4 5 6 7.5, somewhere here. It's 12.5. Okay, 12.5 dB, because the access signal was 15 dB, and for every 2 dB it will be reduced to 1 dB, because our ratio is 2:1. So for every 2 it's 1 1 1 1. In this way we got 7.5. Now the excess audio signal above the threshold can go only up to minus 7.5 dB higher. So from here, counting 7.5 up, we got here. Okay, 12.5. So in this way, the final peak amplitude is 12.5 dB, and our original peak amplitude was minus 5 dB, and the ratio was applied at 2:1, and the threshold value is minus 20 dB. So do you think that every time we have to do all these maths and manually? No, we don't have to. For this purpose, audio compressor is made, and audio compressor does all these maths for us in a very simple manner. Okay, this thing, audio compressor, is like a calculator which does all these maths for us. Okay, in a very simple way. I'll show you here now. Now let's see here. I have sine wave audio signal at minus 5 dB. Let's see. Its peak amplitude is minus 5 dB, and I have put here an audio compressor, and now let me activate it. Now the threshold is set to minus 20 dB. The ratio is set to 2:1, and the attack and the release is set to the fastest possible. Now this same condition satisfies in our this case, because we have an audio signal at minus 5 dB peak amplitude, and we have set threshold to minus 20 dB here, and the ratio is 2:1, and attack and release is to the fastest possible. So now let's see what we get. Minus 12.5. Here also we obtain minus 12.5. Here it's minus. I forgot to write. Because above this 0, the audio sound will be clipped. Okay, distorted. Everything will be in this minus range. This is simple to understand. So you can see all these maths was done by this audio compressor directly. Okay, in a very simple way. You can see minus 12.5. So now let us see about makeup gain. Before, the sound was at minus 5 dB here, and now the sound is at minus 12.5 dB here. So it is decreased, but we want louder sound, and with compressor we are decreasing the sound. Why? Actually we are not decreasing the sound, we are decreasing the dynamic range of this audio signal, and now we'll increase this sound with the help of this makeup gain. Now see, You see, we can rise. It's auto makeup gain. Okay, just you can uh, uh, increase it. Now just make sure you don't clip the audio signal. So this final output with the help of makeup gain will be louder, and in this case the quieter part of the audio signal can also be increased to some good extent, because before applying audio compressor the louder part was too loud, and with a little bit of increase in the volume, in the amplitude, the sound, there is a high possibility the sound will get distorted, okay, clipped. But with the help of audio compressor, we can decrease the dynamic range, so that louder part will be little quieter. So now we can increase, and while increasing we can hear that quieter part also loud. So in this way the sound is louder, and obviously that louder part will be loud while applying the makeup gain. The purpose here is to increase the quieter part loudness. Now we'll be understanding the audio compressor in total, and we will be focusing in this part more to the attack and release section, which we simply omitted in our previous graph math section. I simply just said attack and release to the fastest possible, but here we'll be doing the analysis of attack and release. So let's begin. So you can see here I have my audio compressor, and its setting is like this: threshold minus dB, ratio 2:1, and attack and release is fastest possible. So before applying this audio compressor, let's see our audio signal. It's around 6 dB, and this around it's minus 9 dB. So so this is our audio signal. Okay, I made this audio signal especially for this video, so that I can make you more clear. So here we have a white noise at around minus 6 dB, and we have our sine wave audio signal at minus 9 dB, and our audio compressor setting is this: threshold minus 8 dB, ratio 2:1. Okay, and attack and release to the fastest. So now we'll be looking on attack and release section. So let's begin with attack and release to the fastest, and let's see. Currently the compression is off. You see here. Wait. You can see it's like in this 0 dB. Okay, here just align it here, and this somewhere here just below this minus 20 dB here. Now I will apply audio compressor. Just notice, you see, when I applied audio compressor, before it was here, now it's here. It has decreased from here to here. You see, but this sine wave audio signal was here before applying audio compression, and now after applying audio compression it's still there. So why? Because our this white noise was at minus 6 dB, and our threshold is minus 8 dB. Okay, so our white noise crosses the threshold value. So the compression is applied to our white noise. But in our sine wave audio signal, before it was at minus 9 dB. So it didn't cross the threshold value, okay, because threshold value is minus 8 dB. So no compression is applied to our sine wave audio signal. So you see, before also it was here, now also it is here. But to our white noise, before it was here, now it has decreased from here to here. And another important thing, this attack and release is to the fastest possible. And what does that mean is, when the audio signal crosses the threshold value, the compression is applied then and there, okay? The compression is applied fully then and there. And you can see when the audio signal was at minus 9 dB, this sine wave audio signal, no compression was applied. But as soon as this white noise portion came, which was at minus 6 dB here, and the compression is applied then and there here quickly. And similarly, when the audio signal falls below the threshold value, there should not be compression. So when the audio signal is at this minus 9 dB again, the audio compressor is released, is made to off then and there. Here you can see when the audio signal is down and the audio compressor is off, and this minus 9 dB audio signal is flowing at its original amplitude level, okay? You see, it's moving at its original peak level, because the release was then and there. It says compression has to be applied then and there. So after this, its start point was here, and end point was here. The compression has applied then and there from here to here straight, and the release, the compression is stopped then and there here. This is very important to understand. And the next audio signal, which is lower than the threshold value, is not affected by the compressor, okay? And you can see this its next audio signal is played at its full potential, okay, at its original full peak level, which is minus 9 dB here. You can see here. Just observe it. I'll be playing for some time. Now we'll be looking at slowest attack and slowest release. First let us observe the audio signal. The compression is active. So you can see when the attack and the release was to the slowest possible, it's decreasing this white noise slowly here, and the most it can decrease is here. It's slowly decreasing here, and it's taking the time total this 400 milliseconds to come to the fullest compression state. And one thing you might have noticed, when this attack and release are made to the slowest, this white noise is not decreased to that amount which was decreased when this attack and release was to the fastest. When the attack and release is made to the slowest, it's this white noise is decreased less, and there is a reason. I'll be explaining this. So you have understood this attack, okay? Slowly it's attacking, and it's taking 400 ms to come to the fully compression state. And also remember, the total decreased amount of white noise is less when the attack and release is made to the slowest, compared to when the attack and release was made to the fastest. And I will be explaining this a little later. Now let's see of release. Wait, it's slowly attacking. So now what you can see, this audio signal, this sine wave, which is at minus 9 dB and threshold is at minus 8 dB. So this audio signal should have been played at its full peak level, but you are seeing here it's slowly increasing and it's reaching to its full peak level here. Okay, why? Because the release amount is 4000 ms, okay, milliseconds, and when this audio signal is lower than the threshold value, here must come to stop then and there, and there must not be any audio compression done to the audio signal which is below threshold value. But here in our case, the next audio signal is minus 9 dB, which is below the threshold value. But you can see our next audio signal is not played at its full peak level. Why? Because the audio compression is released slowly. When the release is made to slow, okay, slowest possible, here in our case 4000 ms, it's saying that when the audio signal is below the threshold value, the audio compression should come to fully stop slowly, and here up to here the compression is applied. But when the audio signal falls below the threshold value, the release option is saying audio compressor to come to stop slowly, okay, and it's taking 4000 ms to come to the full stop. So up to the time the audio compression is taking to come to the full stop, the next audio signal is also affected. So you can see it's taking 4000 ms, and only after that it will the next audio signal which is below the threshold value will come to at its original peak level. I will try to explain this more properly here. Now just notice it's slowly attacking and it's slowly releasing. So now I will decrease this release to half, okay, somewhere here, and now you'll notice you see it's taking now little bit less time to come to the full peak level. It's the previous audio level. So you can see it's taking now less time for the next audio signal which is below the threshold value to come to its original peak level. Just notice, okay, wait, it's slowly attacking. You can see, yeah, from somewhere here it's coming to the its original peak level, slowly attacking and slowly releasing. And you can notice from here 9. I will decrease more this release. You can see, yeah, you can notice here it's 9. Now our audio sine wave is coming to 9 soon from somewhere here. Just notice in the beginning it's not at 9 in the beginning, and after some time it's 9. Just notice here, yeah, minus 9.0 point something something, and after some time it will come to exact minus 9. So again I am making the release option more. Slowly it is attacking and slowly it's releasing. So you can see the total decrease in this white noise is less when the attack and release is made to the slowest possible, but this white noise was decreased more when this attack and release was made to the fastest possible. Why? Because in this setting, when this attack and release is made to the slowest, the next audio signal, okay, which is this in our case this sine wave, this is also decreasing, and our audio compressor um, is supposed to decrease the loudness in total aggregate. So this decrease is also counted. So this decrease plus this decrease is the total decrease. But when our attack and release was to the fastest possible, the total decrease was here, only here, as the attack and release was fastest. So when the compression is acted, it will act fast then and there, and when the compression has to be off, it will be off to then and there. So the next audio signal is not affected in that case, but in this case, when attack and release is made to the slowest, the next audio signal is also affected, and that next audio signal decrease peak level is also counted. So this white noise here, this decrease and this decrease is the total decrease. Now I'll freely play in other setting, just notice it yourself. Now fast attack and slow release. Now slow attack and fast release. Now let us talk about makeup gain. Now this audio compression is off, and you can see this dynamic range of this audio signal. Okay, here, like this, here, and this dynamic range between this white noise and this sine wave audio signal. This, and this white noise is here, in this line, and sine wave somewhere here. Now I am activating audio compression. Just notice. Now after the audio compression is applied, white noise is decreased from here to here, and you can see this lead to the decrease in the dynamic range because before white noise was here, so from here to here the dynamic range was from here to here. Now it's from here to here, you see. But this also lead to decrease in the amplitude of an audio signal. Okay, so makeup gain helps to mitigate this loss in the audio signal. So you can see here, this is our final audio signal after audio compression is applied. And when we apply makeup gain, this makeup gain will help to boost this audio signal, which is the final product after audio compression is applied. And just see, now it's here. Simply audio compression is applied and the audio signal is compressed, and this is our final. There is no makeup gain applied. Now I'll apply. Just notice it's here, somewhere here, this white noise here, just align. Okay, somewhere here. Now I am applying makeup gain. Okay, you see. Now it's here. Before this white noise was here, somewhere here. Now it's here. So this makeup gain helps to boost the audio signal, which was made quieter by audio compressor. And you can see this dynamic range is not affected. It's not that makeup gain is only boosting the lower audio signal. Okay, it's boosting the total audio signal that was obtained after the audio compression was applied. The proportion, the dynamic range of the audio signal which was obtained after the audio compression was applied is not affected. So it's not that makeup gain is increasing only the this lower audio signal. It's increasing the audio signal, the total audio signal which was obtained after the compression was applied. So that dynamic range is not affected. The audio signal which was obtained after the compression was applied, that audio signal dynamic range is not affected when makeup gain is applied. You see, after makeup gain, this audio signal is here, but let me reset. Now when the makeup gain was not applied, it was here. You see, when makeup gain was not applied, it's here, but when the makeup gain was applied, it was somewhere here. And this dynamic range is not affected when the makeup gain is applied. This will increase in proportion. This very important to understand. Now let us see the practical demonstration of audio compressor. So here I have 3 audio tracks. First is the source, which is at minus 3 dB true peak, and the second I have just amplified or normalized this first audio track at true peak of -1, and this third audio track is the compressed version of first audio track, okay, of this source. First is the source, second is the amplified or normalized version of the source at true peak of -1 dB, and the third one is the compressed version of the source at true peak of -1. Now let us examine the audio waveforms of all these three audio tracks. So basically what we see, audio waveforms of audio track 3 are bigger, and the audio waveforms of this first audio track are the smallest one in this 3 comparison, okay. Also one thing here to notice is this audio track 2 and audio track 3 both are at true peak of -1 dB, even though the audio waveforms of track 3 are bigger, which will obviously sound loud, okay. So why is this happening? This is happening because audio track 3 is the compressed version of audio track 1. First, the audio signal of audio track 1 is compressed, and then gain is applied. In this way we get audio track 3, okay. So here the dynamic range of this first track is first decreased, and then gain is applied, okay, which is the result, and it is in track 3, okay. Whereas here in track 2 it is simply the normalized or amplified version of track 1, okay. Simply amplification is done to this track at true peak of -1 dB, and we get this. Here in this track no dynamic range is decreased. This track and this track are having same dynamic range, okay. Simply this track 2 is the amplified version of first track. First track peak amplitude is at -3 dB, and second track peak amplitude is at -1 dB, okay. Simply amplification is done to make sound louder. No dynamic range is compressed. So this is the reason why this audio track 3 audio waveforms are larger, bigger than the audio waveform of track 2, even though they are having same true peak. Since this track 1 is just amplified to get track 2. So in this region, if you see the highest peak amplitude is here, okay, this. Simply amplification is done to this whole audio track, okay, so that we'll get track 2 which is at -1 true peak. So a little bit of increase in this signal, it will reach to -1 dB, and when this audio signal will reach to -1 dB, the amplification process will stop, okay, because it is what our target is. So this is obtained, okay. In this way the lower signal don't get that much opportunity to go up, because the dynamic range is not decreased, and simply amplification is done. But here the lower audio signals are also getting opportunity to rise. Here you can see, because the dynamic range of this audio signal is first decreased, and then the amplification is done. So this is obtained. So this is the difference between simply amplifying the sound to make louder and first compressing the sound and making sound louder. Okay. In this regard, this track 3 will sound louder than all. Obviously this track 2 will sound louder than 1, okay, because track 2 is the amplified version of track 1, okay, but this track 2 and track 3 are having same peak amplitude. Even though they are having same true peak level, this track 3 will sound louder, because in track 3 these lower audio signals are also getting opportunity to rise, which in track 2 the lower signals are not getting that much opportunity to rise. Okay, this is the practical demonstration of audio compression. Now obviously we'll hear first. I thought to describe so that it will clarify you more properly. Okay, now we'll listen.